What is wind shear and how does it impact hurricanes, other tropical cyclones? Tropical cyclones, tropical storms, hurricanes, typhoons, etc. are large warm storms. There are two forms of wind shear in the atmosphere. One is in the vertical. Vertical wind shear is the most influential as far as tropical cyclones are concerned. Vertical wind shear is the change in direction and speed of winds at increasing heights in the atmosphere. This image of tropical storm Nadine was taken on October 12, 2018, as the storm was experiencing strong vertical wind shear. Nadine appeared to. When strong vertical wind shear is present, the top of a tropical storm or hurricane can be blown hundreds of miles downstream. In this case, the storm can become very lopsided or tilted in the vertical and begin to unwind as dry air is drawn in and or the flow of warm, moist air into the entire storm is disrupted. Strong wind shear can occur when the jet stream extends over tropical waters and creates a zone of rapidly increasing wind speed at progressively higher levels of the atmosphere. During a typical, there is often a strong jet stream over eastern North America and even over the western part of the Atlantic basin. This configuration, however, the configuration of the jet stream, or lack thereof over the eastern Pacific, often helps to boost the numbers of tropical cyclones in that basin. Vertical wind shear is also a major player in the less talked about wind shear. Horizontal wind shear is the change in direction or speed of winds over the surface of the ocean. When a storm encounters strong horizontal wind shear, the storm can be whisked away or shredded by strong unidirectional winds. An example of strong horizontal wind shear may be along the Atlantic coast of the United States with the approach of a strong or blast of colder air. In this case, wind shear may not always cause a tropical cyclone to weaken. In some rare cases, wind shear in low to moderate amounts can cause a tropical cyclone to strengthen. Wind shear can push a tropical cyclone into warmer waters, which are more favorable for development. Just like a sport-tuned exhaust system can give the motor on an automobile more horsepower, wind shear can also vent the tropical cyclone just enough to allow it to strengthen. Increasing winds blowing from the same direction as the circulation around a tropical cyclone can cause the storm to spin faster and strengthen. Areas of wind shear can be difficult to spot. Forecasting areas and intensity of wind shear can be more challenging than forecasting the strength and movement of a tropical cyclone itself. This is because wind shear, like the rest of the atmosphere, is constantly changing, may not be easily detected and rarely remains completely stationary. Tropical cyclones are a fragile beast. As strong as tropical cyclones can become, they are rather delicate phenomena. Tropical cyclones generally need a tranquil environment to first form, maintain strength, and or continue to strengthen. Tropical cyclones are born from a broad area of rising warm air that creates low atmospheric pressure. As this continues, the mass or rising air begins to rotate faster and faster. The more the air rises, the lower the pressure and the faster the air tries to rush in to replace it, which creates the high winds. While some tropical cyclones can form and strengthen despite moderate wind shear, such storms are often torn apart by it or never get a chance to develop in the first place. For the forecast for your local area and your travel destinations, search for location/city.
Raindrop, drop top smoking, no cooking the hot pot. Fucking on your bitch, yeah, that. Looking up, open the park pot.